Afternoon, glassmaking, 1,000 years of innovation, making nice things. Nothing works without glass. So please take a seat. So I have the big honor to have two of the key brains of this industry. So Hartmut Zahel-Mahlberg from Schott and Horst W.Apel from Corning. So let's start with a very short teaser, who you are, why you love photonics, and please, Hartmut.
Yeah, thank you very much for having me here. This morning it was asked what the people were dreaming of, if they were dreaming of photonics. So actually I was dreaming getting a rocket scientist, but unfortunately I just made it to physics in high school, and then I ended up with a degree in business administration. But now I'm back on track. I'm within optics. I'm responsible for our optical glasses and for our components. And yeah, why I'm finding it fascinating is actually what you, Reinhard, this morning said is our challenge being recognized as an industry. I think the reason why we are not, because we are an enabler of many industries, and we as material providers are even enabling you as enablers. Yeah, but that is where the fascination I have with it, because it's so dynamic, it has so much potential, and yeah, I like what I do.
Thanks for coming here. Dear Horst, please.
Yeah, my name is Horst W.Apel. I'm 64 years old, married since 36 years, with two adult sons that are out of the house. Yeah. And in the meantime, we have got 3 grandchildren that I love a lot, and I'm a PhD in chemistry. And I worked for 11 years in the area of analytical instruments here in Europe. And in 2001, I joined Corning in Wiesbaden, and my first job was I was responsible for this big company located in Oberkochen that starts with a C and ends with an Alzheimer, you know. So this was my first job. And in the meantime, I'm responsible for business development for Corning here in Europe, Middle East, and Africa. And until approximately 960 days ago, also for Russia, but this is discontinued, as you can imagine. And you asked the question about what fascinates me. There's the following story. About 21 years ago, the astronomers from the Hubble Space Telescope, they directed the telescope to position its base a little south of the Orion star constellation, and to a place where they assumed there wouldn't be nothing, right? And then they did this short before Christmas. They left over Christmas, returned in the new year, and then they downloaded the picture they recorded from this tiny spot in the universe that was integrated for 11.5 days. And then this was the wow effect. Until that moment, there was a discussion going on our planet whether there were more sand cones on our planet or whether there are more stars in the universe. And this one picture, if you want to Google it, it's the ultra-deep field picture of Hubble Space Telescope. If you Google that, you will see that just this tiny spot of the universe contains 10,000 galaxies, and no one was aware of them before. And the spot they examined was kind of, if I would place a euro underneath the roof here, that was the tiny spot. If we would like to map the entire universe, it would take 12 million additional similar pictures to get a full mapping of sky. And since this is so fascinating for me, I could talk hours about this, but I give back to you if you...
Well, thanks for sharing. So this is maybe the answer for the Generation Z. We need to create heroes' journeys for the kids. So something that really, wow, tears them into our industry. Now, sustainability, global zero. So I just mentioned in the morning, so glass makers had to go from one place to the other some 100 years ago because all the wood was chopped, all the forest was gone. So what is the future of sustainability, global zero for the glass makers? Hartmut, please.
Yeah, we are of course as well confronted with this challenge, highly energy intensive, you can imagine. And we took the challenge. So 2019, that's our reference year. We calculated that we have a CO2 footprint of roughly 1 million, scope 1 or 2 and 2, those of you who are familiar to those calculations, and yeah, heavily dependent on fossil energy, gas, and partly, luckily, already as well electricity. I can already spoil a little bit. Meanwhile, some years afterwards, we are on track. We have saved 60% roughly. Major lever is electrification, and that's as well the major lever we are continuing to do. It's technology change, yeah. But you can imagine it's challenging. At Schott, a lot of fossil energy, but that's not the only challenge. The other challenge is we do have at least 200 different glass types, at least, if not more. We have all kind of different tank sizes. So the ones I'm responsible for in optical glass melting, that's the easy ones, yeah, because they are partly the smaller ones, just a desktop size, yeah. But you imagine in the home tech industry or in pharmaceutical industry is much, much bigger. So many glass types, and those, we've talked about this today as well. It's about chemical properties, it's about mechanical properties, and of course about optical properties. And we need to switch them within a technology change, and firing with a different firing technology does have an impact on the glass properties. So what we did recently is we have done our first test with hydrogen powering of an optical glass. So we took a catalog glass, and together with the large component supplier, we made a test, and we have proven now that we can produce in specification, and we are on track, but it's still a long way to go, but we will make it, yeah. So the objective is 2030 being the first CO2 neutral specialty glass producer.
2030 is challenging. That's not so long, huh?
Yeah, it's,
wow.
but
wow.
there's a roadmap in place. Yeah.
Yeah. Horst, what is Corning doing?
Well, Corning is taking this topic very, very serious. So what I can announce is during the past 10 years in a row, Corning was awarded from the US Department of Energy as the Energy Star Partner of the Year. So we are continuously improving our processes. You know, we are releasing once per year a sustainability report that anyone can download if you want. And in this sustainability report, we're not just looking to energy, we are also looking to fair payments, we are looking to fair treatment of genders, for example, because everything fits together at the end of the day. The Corning perspective is we say we have a footprint, a sustainability footprint. And the footprint is basically what we are doing, how we operate, how this reacts, what is the outcome there. And I can give you an easy example for the footprint. For example, what we have done just recently, we have signed a contract with one of the largest photovoltaics plant here in Europe. Actually, it's located here in Spain. And this will enable to supply our entire European organizations with electrical energy to the fullest extent. The plan for the next upcoming 4 years is to also perform identical steps in the US, for example, and to have until 2030 all operations in the US and in Europe where we cover the electrical energy by renewable forms. Wow. Right? But now there is a second thing, which I said is called a handprint. Right? The handprint for us is what do other companies are doing with our products. And I guess the easiest example is our business for our environmental filters. As you probably know, Corning is manufacturing ceramic substrates that since more than 50 years are making our air cleaner. Nowadays, we are removing 99% of the poisons coming out of an exhaust system from a car. As a matter of fact, we are now, during the last 50 years, we have removed 4 billion metric tons of nitrogen oxides, of hydrocarbons, of carbon monoxide, and of course on fine particles from the exhaust systems of our cars. And this is basically our handprint. And handprint and footprint basically belong together.
So that means you could fly around the planet for the rest of your life and you would have a green balance. Very impressive. So when we prepared the panel, so then I learned about that glass makers are doing something with laser fusion. So I could not believe it. So Hartmut, please explain laser fusion. Why is this a market opportunity?
Yeah, it's a big market opportunity, and it's of course connected as well, possibly in future, to getting CO2 neutral. Because one thing what I didn't disclose about the challenges we have with getting CO2 neutral is of course as well infrastructure, getting the energy, the CO2 neutral energy available, and having it as well as at competitive prices. And here, laser fusion could play a major role in future. I don't dare to say when it will happen, but meanwhile, what I understand that scientists are getting more confident it's getting closer or more tangible, because we had, with a net gain event at Lawrence Livermore, end of 2022, I think we had an industry change. Yeah? An industry change in that sense that it switched from science to startup, or to startup meaning to companies getting interested in commercializing it and as well industrializing it. Yeah, and that makes us as well very confident, and that's a path we would like to support, and we do support it with our laser glasses. That's the one part, it's for the active laser generation part, and the other part is in the beam pass components that we provide. Yeah. And this change in this change of dynamics from science to startup makes us confident it will happen. But looking forward, I think there's still a far way to go, because there's, as far as I understand, still fundamental issues. I would assume those fundamental challenges are not that much within this community here, or let's say within the optics part of it. There is a lot of challenges, but things are in place. Yeah, how to scale up, and solutions are in place, so they shouldn't be showstopper challenges in the optics. But within the fusion process itself, there's probably fundamentals to be solved to really make it industrialized and scalable.
Yeah. Well, this world is facing a dilemma. In 2020, the world capacity of energy was 20 terawatts. In 2060, some people predict that we will require a capacity of 60 terawatts. And at the same time, of course, we are increasing renewable energies, no doubt about this. But at the same time, we want to stop using fossil fuel to the fullest extent. So this leaves us at 2060 with a gap of approximately 30 to 40 terawatts of energy, of capacity. And no one at the current time knows how to close this gap. And therefore, as Hartmut said, we need to look for all kinds of possibilities to close this gap. Laser-induced nuclear fusion is a great possibility. So how it works is they fire high-energy lasers into a target. The target is like 2 millimeters in diameter, and it contains hydrogen isotopes, basically deuterium and tritium. And then the inferno breaks out. They introduce about 1.3 or 1.8 megajoule into this cell, and then the nuclear fusion starts. It creates a temperature of 100 million degrees Celsius and a pressure of 10 million bar. To give a perspective of 10 million bar, you have to put 10 battleships on your thumb and focus the pressure of this battleship to a size that is 10 times smaller than the diameter of your hair. 5 microns times 5 microns, 25 microns. That's the pressure we're talking about. And then the nuclear fusion starts, and it creates helium. That's what our sun is doing, fortunately for us, every other day, right? and we're getting out 3 megajoule. So what is the difference? 2 megajoule of difference. So what is 2 megajoule? That's 1 bar of chocolate. That's it. Not more. And you know how long a chocolate lasts if you open it at the TV, right? So there are a bunch of challenges. We could speak very long about these challenges. Let me just pick out 1 or 2. First of all, the fuel. The fuel, deuterium, is plentiful available on our planet. Every 10,000 molecule or every 10,000 atom of hydrogen in your body is deuterium, because that's the isotope distribution on our planet. Okay? The other isotope, which is tritium, that contains 2 neutrons and 1 neutron in the nucleus of the atom, is not available. In our stratosphere, there are available about 2 kilograms of this material, of this gas, but in the entire atmosphere, created from from space radiation. And the only way we can make tritium is we can do it in high-pressure nuclear fission reactors. And the current world inventory of tritium is approximately 20 kilograms. And now comes the bad message. This stuff is radioactive with a half-life time of about 12 years. So in 12 years from now, we only are going to have 10 kilograms of this material. And it's quite expensive. So tritium and deuterium both are required. Tritium is a challenge, but with the laser-induced, I'm talking too long, am I? Right?
That's okay. I love your hobby.
Okay.
I love your hobby.
I give you
we know what you will do after retirement.
Photonics is emotion.
Well, so if it's okay for you, I continue. So they need deuterium and tritium, because if you do the nuclear fusion with deuterium and tritium, just 100 million degrees Kelvin are required. If you do it with deuterium and deuterium, you need 400 million, okay? The big problem we face is the energy we need to put into the lasers to create a 1 megajoule pulse that lasts about just 1 nanosecond. We need to enter 300 megajoule at the current time because the lasers are not efficient enough.
Yeah, we need better lasers. But that's not for the glass makers, yeah?
Yeah.
Now that's now to something completely different.
Yeah.
So I recall my dear friend Bernhard Gress was hired by Google when in the first time of the Google class, and he invited me to the Google campus, which was, that was when the Google campus was super hype. So since then, I follow the augmented reality, which is also a subject for glass makers. So is this something for Schott and for Corning, augmented reality?
Definitely. Yes, the short answer is yes, definitely. Just last week we did have our inauguration of an expansion of capacity in Malaysia factory for optics components, and one of the target applications is augmented reality. But let me come back to why we are confident in it and what technologies we are following. So confidence we already talked about a lot this morning is due to the consumer electronic companies globally, not only from the US, but as well from China, heavily investing here. Of course, we are all aware the must is AI, yeah, that's a must, and the vision, or let's say the promise, is AR. Yeah? And the promise, AR is not the gadgets we are seeing so far, Snapchat, Meta, Ray-Ban, Microsoft, you name them. Yeah, that's not the promise. The promise is a full immersion experience coming up, or everybody is waiting for.
I have to challenge you. So this is for discussion. Daniel Kahneman, who died this year, he was writing a book about thinking fast, thinking slow, and the fast brain lets you drive a car. So if you text in your car, the slow brain gets in and you smash against the tree. So now, what do you think? So because gigapixel we saw in the glasses, I'm really very skeptic. It's like 3D television, you know? There was 1 year you could only buy a 3D television. You cannot buy this anymore. We didn't want to have it. So now is the vision for you to get millions of colors and have the glasses better than reality?
Well, first of all, that's the vision of the consumer electronics industry, and that's not our vision. Our vision is that we want to enable.
You're following your.
We want to enable what they are working on, and our assumption is that it will not be done with classical optics, because it's simply by Etondue rule you cannot do classical projection with your holographic image. So what we believe in is that it will be waveguide based, and either it will be refractive based or it will be diffractive based. We trust that this will be possible. Both technologies have their pros and cons. And at the end of the day, it's about usability. Usability meaning for consumer experience, that's image quality. The consumers will expect a perfect image, which we don't have yet today. Secondly, they will expect that it's a light and form factor, nice device, not so big and what we have seen, and energy efficiency. Beside, of course, how to steer it, that's not up to us, that's up to AI. But about optical performance and about lightweight and energy efficiency, there's pros and cons for diffractive and refractive waveguides, and we assume one of them will make the race or they will coexist, and we are preparing for both, therefore.
Wonderful, it sounds like a plan. Who in the audience thinks that augmented reality glasses will come in our everyday life in 5 years? Who thinks, yes, we will all have it at home?
Okay.
I'm wondering, is it a big overlap with CEOs? I hope so.
Okay, so we're coming
CEOs.
to the end. So maybe a last word, future trends, a wish, or so you, the glass makers, without you, nothing works. We cannot do anything in optics and photonics. Semiconductor also needs more and more glass. So what are the final words or the wishes, big wishes?
Well, I spent a lot of time to talk about nuclear fusion, of course, so I give you back some minutes.
Enjoyed it.
No, for me, this is not a corporate point of view, it's just my personal point of view. Coming back to energy, it's for the entire history of mankind, when we created energy, we were destroying something, right? We are burning wood, we are putting fuel in our cars, and we are burning the hydrocarbons. We are burning oil. We are splitting uranium 235 nucleuses in nuclear fission reactors. When is mankind learning that we may do the opposite way by putting things together? Like nuclear fusion is, we are putting together two hydrogens making helium. Our sun is doing this since 4.5 billion years. Oh, our plants out there, they're using a little bit of UV light. They're using a little bit of carbon dioxide, a little bit of water, and a little bit of nitrate from the soil to make carbohydrates, right? And maybe in the future, we will be smarter in this respect.
I guess we all share this comment.
And if we can participate, you by delivering the laser glasses, the neodymium doped glasses, and Corning the fused silicon material for these projects, I think this would be wonderful. And the world in 20, 30 years from now could be much, much better. That's my dream.
Hartmut.
Yeah, you asked for wishes. So first of all, there's a message, and then there's two wishes. The message is glass is more than 2,000 years old, and it's still innovated. Yeah, there's still room for innovation. You mentioned just semiconductors. We just ramped up a new strategic business field at Schott to support their specific requirements for future interlayers. And then my two wishes. First of all, I think what we are doing here today, I think cooperation, that's bringing us forward, and you see already perfect harmony between two competitors here on the stage. But I think the cooperation is really important, especially if it comes to innovation, in addition to persistence, what we just heard from Chuck. And and last but not least, I would personally hope that by deglobalization we don't see this confronted with some slowing down and not using the efficiency of really, this morning somebody formulated for a really interconnected industry globally and not into different regions and disconnected, yeah.
Thank you very much. After this very inspiring path to a green future, I'd like to have some inspiring questions from the audience.
So it's Mike Powell from Renevo Capital. So the conversation about fusion reactors is amazing, but why not take advantage of the fusion reactor up in the sky and build collectors on the ground and then store that energy? And that kind of makes me wonder whether either Corning or Schott actually make many glass substrates for solar panels, and if not, why not?
Yeah, we worked on solar panels in the past, and we exited this business for photovoltaics. Main reason was there was It was in the midst of the 2010s somewhere we exited the business because main reason there came overcapacities from China. It was a very subsidized business, and despite taking the race for beating down costs on a level where it's really sustainable, we couldn't keep up with the overcapacity. So
I guess we should see that the glass-making industry is more than 100 billion, and the specialty glass is about a 10 billion something. So that means glasses for windows or for solar panels is another game than having the best glasses in the world for the best optics in the world. So. Yeah, I would not chase the cheap glass and be even cheaper. So we want to have these companies being sustainable, green, and the best glass, because we need the best glass. Do you have another? You want to say something still?
I just want to say, but nothing is forever dead. Yeah. So currently, what we are doing, coming back to your space
nothing
idea,
is forever dead is not.
We are supplying the right materials to make solar panels in space feasible.
Yeah. So from the Corning perspective, as a matter of fact, we just purchased a company called Hemlock Semiconductor about 3 years ago, I guess. And this is the biggest producer from polysilicon in the US market. So we are in this business now. And to answer your question, the sun is not shining 24/7, right? So we have nights, we have winters. And what if the sun doesn't shine? What if there is no wind blowing? We have requirements for energy at the night as well. So the flavor of nuclear fusion is it can run 24/7, and I don't see too sophisticated storage possibilities for electrical energy at the current time. There's a big gap.
Wonderful. So we're running out of time. I get the signs from left and right. So thank you very much for this very inspiring talks.